Hi, welcome to part 8 of the video series about laws of motion. In the previous video, we have solved some examples related to the universal law of gravity. In this video, we will try to understand the topic better by solving two more questions. In the first one of these questions, we are asked to calculate the difference in the weight of a climber at the top of a mountain and at the ground level. Mass of the climber is 80 kgs and the height of the mountain is 5000 meters. The question also provides us with all the constants required in our calculations. To calculate the difference of weights, first we need to calculate the weight of the climber on the ground and then at the top of the mountain, and then subtract these two values. Let's start with the weight of the climber on the ground level. If an object is on the ground level, as a distance we use the radius of Earth. There is an easy method of calculating the weight of an object on the surface of Earth, but we will see it in the next question. For this question, let's use the formula for the force of gravity in order to see both methods in action. The next step is making substitutions. Universal gravitational constant is 6.67 times 10 power to negative 11. Mass of the climber is 80 kgs. Mass of the Earth is 5.98 times 10 power to 24. And the radius of Earth is 6.38 times 10 power to 6. Weight of the climber on the ground level is 783.93 newtons. Now, let's calculate the weight of the climber at the top of the mountain. Unlike the previous case, if a climber is at the top of the mountain, the distance between Earth and the climber will be equal to the sum of the radius of Earth and height of the mountain. In this case, the denominator in the formula of the gravitational force will become r plus h squared. We can proceed with substitutions, but don't forget to add 5000 inside the parentheses in the denominator. Weight of the climber at the top of the mountain is 782.7 newtons. Let's recall the values of weights. Weight on the ground is 783.97 newtons and weight at the top of the mountain is 782.7 newtons. The task was to calculate the difference of these weights. 783.97 minus 782.7 is equal to 1.23 newtons. Even though the next question is slightly challenging than the one we have just solved, the solution will be very similar. According to this question, there is 19% difference in the weights of an object on the surface of the Earth and while orbiting Earth. Our task is to calculate the height h from the Earth's surface at which the satellite is orbiting. Mass of the satellite is 300 kgs. As in the previous question, to solve this one, we will try to split the solution into two parts. First part is then the object is on the surface, and the second part is when the object is orbiting the Earth. As we mentioned before, there is an easy way to calculate the weight of an object while it is on the surface of Earth, and we have already used this method in a lot of previous questions. Weight of an object is equal to mass times gravitational acceleration. Of course, we could use the formula for the gravitational force as well, and the answer was going to be slightly different, since 9,8 is the rounded value for gravitational acceleration. But in the memos of exam papers, both solutions and answers are getting you full mark. 300 multiplied by 9,8 is equal to 2940 newtons. Now let's calculate the weight while the object is orbiting around Earth. In this question, it is given that the weight while orbiting is 19% less than the weight on the surface. Initially, the weight was 100%. Now it is 19% smaller. 100% minus 19% is equal to 81%. we have calculated the weight of the satellite on the surface as 2,940 newtons. Weight of the object on the orbit is 2,381.4 newtons. Once we know the value of the gravitational force, we can use it in the formula. Let's make sure that we don't forget to add the height in the denominator. Weight is 2,381.4. Mass of the object is 300 kgs. Mass of the Earth is 5.98 times 10 power to 24. And finally, the radius of Earth is 6.38 times 10 power to 6 meters. After solving this equation for height, the result is going to be 708,559.05 meters. In this video, we have solved 2 more questions about the universal law of gravity. In the next video, we are going to learn about the normal force and start to solve some questions to calculate it for different cases. Don't forget to subscribe and turn on the notifications in order to be updated about my new videos.